Good afternoon, students. This is Ms. Codner again, ready for the lesson for March the 25th and also for March the 28th. We have basically one more day after this class to get ourselves together. And just a heads up, next class we're actually going to have a quiz on exponents, adding and subtracting polynomials, and also the FOIL and box method, which we're actually going to touch on today. So for today's class, you need a pencil, calculator. I collected the homework, which was 14 out of the 48 or 46 problems that I gave you guys on that front and back side. There is a tan sheet, which I will try to put on the website, but that's going to take a little bit longer. But that was like classwork just for practice. And also some loose leaf paper for some notes. So first things first, I want to review solving equations with polynomials. So for example number 1, we have 2 times 5a minus 12 equals negative 6 times 2a minus 3 plus 2. So the first thing I should do to tackle this will be distribution. So in this case, I'm going to distribute the 2 to the 5a and the 12. And I'm also going to distribute the negative 6 to the 2a and the negative 3. So when I distribute, I'm actually multiplying. So let's go ahead and multiply. So 2 times 5a gives me 10a, minus 2 times 12 gives me 24, equals negative 6 times 2a gives me negative 12a. And a negative 6 times a negative 3 is going to give me plus 18. And then I'm bringing down my plus 2. So before we start isolating our variables or trying to get all our a's on one side equal sign, let's check to see if we can simplify. So if you notice right here, we have a positive 18 and a positive 2. They can be combined to give me 20. And in this case, I'm going to bring everything down just so I can show where all my steps are. So now from this point on, I want to isolate my variables. I want to get my a's on one side equal sign. It doesn't matter if I want to put it on the left side or if I want to put it on the right side. So for most classes, they felt comfortable by putting their variables on the left-hand side of the equal sign. So then that in turn, I need to look at this negative 12a. And since I'm solving, I need to do the opposite so I can move that 12a on both sides. So I'm going to add 12a to both sides. So with me doing that, I'm saying that I want all my a's on the left-hand side. So that means all my constants, or just the numbers, need to be on the right-hand side. So I'm looking at this negative 24. So in order for me to move that negative 24, I'm going to have to add 24 on both sides. And I know you're probably used to just doing, okay, let me do one step, then I do another step. But since I need to get you guys prepared for Algebra 2, we got to practice doing 2 steps on the same line. Okay? So therefore, my negative 24 and my positive 24 is going to cancel out. And my negative 12 and my positive 12 is going to cancel out. So in order for them to cancel out, they have to be opposite signs. So now let's go ahead and combine our like terms. 10a plus 12a gives me 22a equals 20 plus 24 gives me 44. So I want to get a by itself. That means I have to do the opposite of this multiplication, which is division. So I'm going to divide both sides by the 22 so I can get my a by itself. So now 44 divided by 22, that will give me 2. Okay? So yes, we're doing it step by step, but what we're actually doing now is we're combining 3 classes into one. We're combining our adding and subtracting polynomials by adding on multiplying polynomials. Okay, so we're carrying things over. So let's take a look at number 2. So number 2, again, we have b times 12 plus b minus 7 equals 2b plus b times negative 4 plus b. So again, we're going to distribute. And I'm just distributing the b's. I'm not distributing it to that negative 7 because that negative 7 is not inside that parenthesis. So now, let's do our multiplication. So b times 12 gives me 12b plus b times b gives me b squared, not 2b, b squared. Because remember, there's a 1 that is your exponent. And when we're multiplying, we are adding the exponents. That's why it's a b squared. Bringing down that minus 7 equals 2b. And now we got b times negative 4. That's why it's a minus 4b. And again, b times b will give me plus b squared. So now, let's see. Do we have like terms? As you can see on the right-hand side, we do with this 2b and this minus 4b, which will give me a negative 2b. So from here, I'm just bringing everything down so I can see what I need to do next. So I'm solving for b. So one of the things I can do is I can subtract b squared from both sides. And I can also subtract 12b from both sides. Okay, so our ultimate goal is to get our variable b by itself. Notice, b squared minus b squared will give me 0. So they actually cancel out. It's not leaving me a b squared. Everything is gone. This 12b minus 12b, that's going to cancel out. So only thing that's on the left-hand side is my negative 7. So negative 7 equals negative 2b minus 12b, which gives me a negative 14b. And right now, this is working out pretty good because I have my constant on one side of the equal sign, and I have my variable on the other side of the equal sign. So now I want to get b by itself. That means I need to divide both sides by negative 14. And hopefully you all remember that a negative divided by a negative is going to give me a positive. But my answer is not going to be 2 because it's 7 divided by 14, which gives me my b will equal 1/2. Okay? So a lot of people get tricked up. They do recognize the 7 and the 14. Yes, they have 7 in common, but it's the 7. It goes from the numerator divided by the denominator. So the top divided by the bottom. Okay? Next one was number 3. Just going to raise that up a little bit. And if you want, you can pause this lesson, and then we can just simply check our answers. Okay? So go ahead and pause, and now I'm just going to carry on, and you can check your answer. So for those that did not want to pause, again, I'm distributing that 5b to everything inside the parenthesis. So this time we're not multiplying by a binomial, we're multiplying by a trinomial because there's 3 terms there. And then we're going to do the same with the 9 on the other side. So 5b times negative b squared will give me a negative 5b cubed. And it's cubed because my exponent of 1 plus 35b squared minus 5b. Okay, bring my plus sign down. Let me change colors here so we can see both sides. So 9 times 3b to the 3rd power or cubed will give me 27b cubed. minus 54b plus 18. So you're probably saying, oh my goodness, there's too much stuff here. Well, guess what? Do you have like terms? So for the most part, I have a negative 5b cubed here, and I have a 27b cubed. If I combine those two, I'm actually going to get 22b cubed. Notice I didn't do anything with the exponents, because when I'm adding and subtracting, the only thing that the exponents is doing is helping me to pair things up. So now, do I have anything for b squared? Just as 35, b squared. Okay. How about my b's? Well, it looks like I have a negative 5b and a negative 54b. So if I combine those, I get negative 59b. And then what's left over will be my plus 18. So if I look in between all this, I can't simplify anymore. Even though we have b's as our variable, but always ask yourself, are my exponents the same? No, they're not. Okay? So you don't want to just go ahead and just, oh, I see a b, let me just add everything. Make sure you ask yourself the question, yeah, they all have the same variable, but do they have the same exponent? If the answer is no, you're already done with your solution. So number 4 was just a little, let's try amongst themselves. So again, we're distributing. So you have a negative 24x plus 36 plus 4 equals 20x minus 48. Like terms? Right here with the plus 36 and the plus 4. So now I have a negative 24x plus 40 equals 20x minus 48. Want to get my x's. It doesn't matter which side you put your x's on, as long as all your x's on one side of the equal sign and all your numbers on the other side of the equal sign. So if I wanted to do that, let me say if I put my x's on the right hand side. So that means this negative 24x, I need to change to a positive 24x. So that means I'm adding 24x to both sides. So if I'm saying I want my x's on the right-hand side, that means these numbers need to go onto the left-hand side. So I'm going to add 48 to both sides. So what can we cross out? We can cancel out the 24x's, and we also can cancel out the 48's. So now, 40 plus 48 will give me 88. Equals 20 plus 24, which is 44x. Do not forget to bring your variables down. Dividing both sides by 88? No, want to divide both sides by the 44 because we want to isolate our variable. So 88 divided by 44 gives me 2, and that's what x equals. Okay? If you're not sure, if you want to check it, so we had 2 for our x. So we're going to plug in a 2 for all our x's. And we should get the same answer on both sides of those equal signs. So let's think it. Negative 6 times 2 gives me 12. Negative 12 plus 9 gives me a negative 3. 4 times a negative 3 gives me a negative 12. And then negative 12 plus 4, that should give me an 8. So right now on the left-hand side, I have an 8. So let's see if we get an 8 on the right-hand side. So negative 5 times 2, that gives me negative 10. Negative 10 plus 12 gives me 2. And negative 4 plus 2 gives me a negative 8. Forgot to put the negative. And we have the same answer on both sides of the equal sign. So that means that value of 2 is correct for our missing variable. So after we did that, we worked on multiplying binomials by binomials. So the way we can do it, there's two methods. One's called the FOIL method, and one's called the box method. So FOIL, you should have heard this over and over and over again back in Algebra 1. So the FOIL method is just a short version of saying first, outer, inner, last. All FOIL is another way of showing the distribution property. Okay? How we distribute. So in traditional, we said the first. First means the first terms in each of the parentheses. So the first term in this first parenthesis is x. The first term in the second parenthesis is x. So that means when we're doing the first, we want to multiply those two first terms together. The outer means the extreme. So again, the x is the extreme for the outer, but this time the 7 is the extreme to represent the outer. Now the inners will be the inside version. It's almost like this x and the 7 that's out here that we said was the outers is almost like the bread. And then the 5 and the x is like the meat and the cheese of the sandwich. So that'll be the inner. And then the last will be the last terms inside the parentheses. So for my case, it'll be 5 and 7. So I know you're looking at this, you're like, oh my God, the lines, the lines. It's all kinds of crazy, right? So let me simplify it for you. So I said all this is just basically another way to distribute. So as we distribute before, let me flash back a little bit further. As we distribute before, let's say for example 1, we took this 2 and we distribute to everything inside that first parenthesis. Meaning, we took the 2 and we multiplied it to the 5a and the minus 12. So in this case, we're going to do the same exact thing. So my first term, my x, I'm going to take this x and I'm going to distribute to the other parenthesis, meaning I'm going to multiply it to the x and I'm going to multiply it to the 7. So I'm distributing my first term to everything in the other parentheses. After I do that, you see this negative 5? Okay, so I'm circling the number and its value. Okay? And I'm going to distribute to everything into the other parenthesis. So this is what it's going to look like. So I have x times x, which gives me x squared, not 2x. And now x times a positive 7 will give me plus 7x. So that's the first part of my distribution. Now I'm going to distribute the negative 5. So I take negative 5 times x, which gives me a negative 5x. And I take the negative 5 times a positive 7, which gives me a negative 35. So that's how we do it. We just take one term and distribute to the other parenthesis. Then we take the other term and we distribute to the other parenthesis. What do you notice? Hopefully you notice that we have the like terms, this positive 7x and this minus 5x, right in the middle of our expression. We can combine that. So 7 minus 5 will give me a positive 2x. So that's why there's a plus sign in front. And what I'm going to do with the x squared and the negative 35 is just simply bring it down in its same position. So this right here is my expression after I simplified or multiplied my two binomials. Okay, let's look at a couple examples. So example number 1, we have 2n plus 7 times 5n minus 8. So like I said before, I'm going to take my first term of 2n, and I'm simply going to distribute to the other parenthesis. So that means I'm going to multiply that 2n to the 5n, and then multiply that 2n to the negative 8. So 2n times 5n gives me 10n squared. Then 2n times a negative 8 will give me a negative 16n. Do you see how I got that? So now I have a positive 7, and I'm going to distribute that to everything inside the parenthesis. So positive 7 times a positive 5n will give me a positive 35n. And then 7 times a negative 8 will give me a negative 56. What do you notice? Right smack in the center of that expression, I have my like terms. I have a negative 16n and a positive 35n. So once I combine those, I would get a positive 19n. And then from here, I'm just bringing everything else down. I'm bringing the 10n squared down, and I'm bringing my minus 56. And then this will be my final expression. Okay? Number 2. So 8x minus 2y times 2x minus y. What's different? This time we have 2 variables. Don't freak out, because guess what? We're going to do exactly the same thing that we did for the other examples. So we have 8x, and I'm going to distribute that to everything inside the parenthesis. So that means 8x times 2x will give me a 16x squared. 8x times a negative, remember there's a 1 to be there, y will give me a negative 8xy. And you're probably saying, well, how did you get that? If I did that in the expanded form, I would have 8 times a negative 1, okay, times my 2 variables, which is x times y. Now, 8 times negative 1, that's where this negative 8 came from. Now, x times y, I could leave it like this, but to really simplify it, I don't need this multiplication symbol. I can write xy to also represent multiplication. Okay? A couple people got confused with that. But when I do multiplication, I can multiply opposite letters together. That's fine. It's only when I'm adding and subtracting I can't combine them together. So that takes care of the 8x. Now we have a negative 2y. So we're going to distribute that to everything inside the parenthesis. So negative 2y times 2x would be a negative 4xy. And you're probably saying, well, why isn't it yx? Remember, yx, xy, multiplication, you can flip it around all you want. There's no particular order when you're dealing with the multiplication. I just like to keep it in alphabetical order because we're so engraved in our brain to do everything in alphabetical order. Okay? And plus, it's a little easier to identify my like terms. And lastly, negative 2y times a negative y. Negative times negative is positive. 2 times 1 is 2. And y times y is y squared. So, what do we notice? This negative 8xy and this negative 4xy are my like terms. So let's combine them. That should give me a negative 12xy. And then from here, I'm just bringing everything down. My 16x squared is coming down, And also my plus 2y squared is coming down. And then this will be my final expression. So here's number 3. X squared plus 5 times x squared plus 4x minus 6. What's different? This time we have a binomial, which is my x squared plus 5, being multiplied by a trinomial. Remember, anything that's 3 terms will be considered a trinomial. But how you're going to solve this is the same exact way that we just did. I know now it's tough for me to call it FOIL because it's not a binomial. But you know what? I can still do my distribution property to solve for my expression. So we start with my x squared, and I'm going to distribute that x squared to everything inside that parenthesis. So now x squared times x squared will be x to the 4th, because remember, when we're multiplying, we're adding the exponents. X squared times 4x will give me plus 4x cubed. X squared times negative 6 will give me a minus 6x squared. So now that we have that done, let's distribute that positive 5. So we have 5 times x squared gives me plus 5x squared plus 20x minus 30. So, do we have like terms? I think we do. This negative 6x squared and this positive 5x squared. So now, when we combine that, I'll get a negative 1x squared, or just negative x squared. And then everything else is just coming on down. So that's my x4, 4th power, plus 4x cubed, plus 20x, minus 30. So you might ask yourself, is it possible when I do my distribution for me to never get like terms? It is possible, okay? It's definitely possible to never get like terms. So, did a few of those examples, and that was the FOIL method, or distribution, okay? Just another way of saying the distributive property. So now the box method. I know a lot of people got used to the FOIL method, then when I showed them the box method, they're like, oh, I don't like it. I'm like, I know, it's change. You don't like change. You'll be fine. Now with the box method, I'm literally going to draw a box. Okay? Nothing fancy. 4 sides, 4 corners, box. But I notice in my expression here, I have m plus 4 times 2m squared plus 1. Since I have 2 terms, that's 1, that's 2. This is 1, this is 2. So okay. So since I have 2 terms and multiplied by 2 terms, that means I need to have a box to represent each term. So this first parenthesis, I'm going to have my m to represent this corner of the box, and my plus 4 to represent that corner of the box. You may have seen something like this similar to biology. You may have seen it in geometry when you had to do the truth tables. Okay, it's the same concept. So now, up top, I'm going to have my 2m squared represent that side, and my plus 1 represent that side. Okay, so I like to have my top parenthesis or my first parenthesis represent the side portion here. Okay, so once I have it set up, in order to fill my boxes, okay? So you're actually going to multiply to fill your boxes. So this 2m squared, to fill this box right here, I'm going to multiply 2m squared with m. And when I do that, I got 2m to the third power. For this box, well, I'm going to multiply 1 times m, which gives me m. In this box, I'm going to multiply 2m squared times 4, which gives me 8m squared. And the last one, I'm going to multiply 1 by my 4, which gives me a positive 4. Okay? So in order for me to fill my boxes, I need to multiply its coordinate sides, or its corresponding side is more like it. So now, let's look at what's written in red. What's written in red is going to be my solution. And what's going to be helpful is I'm going to put it in order just like I've done when I added, subtracted our polynomials. I always start with my highest degree. In this case, my highest degree, which is my highest exponent, is raised to the third power. So it's m to the third power. So anything with m to the third power, I'm actually going to write that down first. So 2m, raised to the third power is going to be written first. The next degree lower is going to be m squared. So I'm going to put plus 8m squared. The next one is m. So since it's positive, I'm going to put plus m. And then lastly, I'm going to write down my plus 4. Take a look. Do we have any like terms? Remember we just discussed that? Yes, we have the same variable, which is m. But do they have the same exponent? No, they do not. So therefore, this is my final expression. This is that m plus 4 times 2m squared plus 1 simplified. Okay? Taking it down to its lowest. All right? So let's try this one. So I know it seems a little weird at first, but after you do it for a while, it kind of grows on you. So I have a plus 1 times a squared plus 5a plus 4. So now I have a binomial multiplied by a trinomial. So instead of just drawing a box with 4 spaces inside, I'm actually going to draw a rectangle. Because since I have 3 terms up top, I'm going to write my a squared to represent that side, my 5a to represent that side, and my plus 4 to represent that side. And then along the left side, I'm going to write my a and my plus 1 to represent the contents in that first parenthesis. So again, in order for me to fill my parentheses or fill my boxes, I need to multiply its corresponding sides. So to fill in this box, I have to multiply a squared times a, which gives me a to the third. To fill this box, I got to multiply 5a times a, which gives me 5a squared. For this box, I'm multiplying a positive 4 and a, which gives me 4a. This box, I'm multiplying a squared times 1, which just simply gives me a squared. This box here, I multiply 5a times 1, which gives me 5a. And to fill the last square, I multiply 4 and 1, which simply gives me 4. What do you notice? You got like terms. On this diagonal, you have like terms. And we're going to add those like terms together. So once we do that, we start with my highest degree, which is a to the third power. Now I have 5a squared plus a squared, which gives me plus 6a squared. And then 4a plus 5a gives me a 9a. And then I'm left with a positive 4. Okay? And then that will be my solution. So just to prove a point, I'm going to go back to one of the examples that we used with FOIL. Okay? Actually, I'm going back to the first one. So we have 2n plus 7 and 5n minus 8. So I'm going to use this example. Just going to clone it. Come with me. I'm going to use this example to prove a point that we can do this by using the box method. So now taking a look at my terms, I have 2 terms, 1, 2, in that first parenthesis, and I have 2 terms, 1, 2, in that second parenthesis. So that means I need to draw a box that's going to give me 4 spaces. So I have my 2n here, I have my plus 7 there, I have the 5n up top, and my minus 8 following. So again, to fill my boxes, I need to multiply. So 5 times 2 gives me 10, n times n gives me n squared. For this box, I have a negative 16n. For this box, I have 35n. And then for this box, I have a negative 56. What do you notice? Again, on the diagonals, we have like terms. So we're going to add those like terms together. So when I do that, I start with my highest degree, which is 10n squared. Now, negative 16 plus 35 will give me a positive 19n. And then I got my minus 56. In comparison, what you notice? We got the exact same answer. So this is just to prove a point. There may be times it may ask you to do the box method. It may be times it'll just ask you to simplify or just to multiply. So you get to choose if you want to do FOIL method or you want to do box method. Regardless, I will try to give you the choice. But as long as you know that there is another method you can use, I'll be fine with that. But perfectly honest with you, you can choose. There's some people that like the box method. There's some people that likes the FOIL method. Some people like to see each and every step because it's been a while since you've seen foiling. And some people just want to get right down to the nitty-gritty of it, okay? So it's going to really be up to you, but be aware you need to understand how to do both ways, okay? So don't say, oh yeah, I'm totally doing FOIL. I'm never doing box. I don't like box. As long as you recognize that there is a box method and you understand how to fill in those boxes, that's perfectly fine. Okay? So, after we did those examples, we had a couple sample problems, a little class practice. I'm going to try to scan it, but it's going to take a little time for me to scan because my scanner is dead. And maybe poor choice of words, but yeah, basically that's what's happening. So we just did a couple example problems. And what I could do is just write those problems out for you. And then you can practice up on those. And when you come for class, we can check our answers together. So for the first one, you just had to do 3a times 4a squared minus 5a plus 9. So that was the first example. The second one was 2x plus 4 times x minus 4. Okay, third example, we had g minus 3 times 2g squared, see, plus 3g. I think it's plus 3. Yep. Okay. Okay, the fourth one was 2p minus 7 times 3p plus 4. And lastly was y squared times 2y cubed minus 7. Okay. So those were the 5 examples that they did, and it was on a tan piece of paper, and I definitely have copies of them in the classroom. And what I could do, being the fun person that I am, I could write the answers to it right next to it, and you'll have to check your procedure. Why don't we try that? Okay, let's do that. I love how you guys are agreeing with me. So for the first one, number 1, these are the answers. Okay, but I definitely want you to check your steps. So for the first one, we had 12a cubed minus 15a squared plus 27a. For number 2, we have 2x squared minus 4x minus 16. For number 3, we had 2g cubed minus 3g squared minus, oop, my paper's in the way, 6g minus 9. Okay, for number 4, we had 6p cubed. Let me lower this down a little bit, it's starting to cram up in there. 6p, not cubed, squared, sorry, minus 13p minus 28. And then lastly, for number 5, we had 2y to the 5th minus 7y squared. Okay, so if you got all 5 of them correct, congratulations, means you're on your way. Okay, if you got one of them incorrect, maybe because you forgot the exponents, don't forget when you're multiplying, you're adding your exponents. If you got a couple incorrect because of your signs, make sure you watch and pay attention to those signs, because trust me, as we advance a little bit later, those signs are going to be very, very important to remember, okay? Or watch your multiplication, because sometimes a lot of you guys see 3 times 3 and you always write down 6, okay? So take your time and walk yourselves through it, all right? So we had those examples. And then for homework, I will put this on the website. It was 5 problems dealing with multiplying polynomials. So we were doing the same distribution. We could do same FOIL, or you can do the box method, whichever method that you want. But the one thing that I wanted to add was for number 5, and I guess I can say this is a bonus for those that actually got on the website to get assistance. When you have 8 minus 3z squared, now there's going to be times I'm going to be dealing with z's, so I really would like for you to draw like a little line through your z's. The reason why a lot of people, their 2's look just like their z's, so just have to watch out for that. So I have 8 minus 3z, and that whole expression is being raised to the second power. We can do this one of 2 ways. If you're familiar with what's called completing the square, you can go ahead and do that method. But if you're not sure, let's take what we've already learned to solve this problem. So before, we would always say, okay, if I say something is a squared, that means I'm multiplying that base of a to itself 2 times, okay? So I'm multiplying it by itself that one extra time. If I'm saying that I'm raising it to the 3rd power, that means I'm multiplying that base of b in this situation to itself 3 times. This philosophy still stands. This time, my base is 8 minus 3z. So I'm actually multiplying that base of 8 minus 3z to itself 2 times. Okay? So this is this in the expanded form. So from here, we can either do FOIL or we can do the box method. Okay? So I'm going to stop right there and have you finish that up. Okay, so that's going to be how you set up number 5 on that yellow sheet. I was hoping that someone would find it a little earlier, but at least we have something here. So I did remind you guys to keep looking at the website, because once in a while I do throw some cues out there. All right, so you complete the homework, return it in next time. Also, as a reminder, we're having a quiz based on exponents, adding and subtracting polynomials, and the box or FOIL method, okay? And also we're going to do a little bit of solving of a variable, just like how we did in the beginning of this lesson. So it's going to be roughly 10 problems. Again, it's open notes. So if you don't have these notes, please write them down. Don't just watch the stuff and just say, okay, yeah, I got it for right now. Because when you reflect back to it, you'll be a little lost. All right? So do your homework. Only got like basically 1 day left. I'm turning all my grades in. Everything is going to be turned in on the 30th, starting on the 31st and the 1st. I'm getting started with 4th quarter. All right. Talk to you guys.